All right. Small review here, which is an example of an explicit intent. Okay. Yeah, not many people got that one. I like to make my Kahoot questions challenging, but you learned something. So, yeah, opening a website URL, that's one a lot of people pick. That's a very like generic action. We don't know what screen we're going to open when we open a website URL because the user could have like any different browser that they choose, right? So it's like an implicit intent. We're not specifying exactly what we want to do, but for starting a new activity, we have to specify this is the exact activity that we want to open. So that's an example of an explicit intent. Uh, okay, true or false? Okay, yeah, this is kind of like vocab. So no worries if you didn't get this, but yeah, so there's two types of permissions, normal permissions and dangerous permissions. And normal permissions can be accessed. You don't even have to like actually request the user to approve that permission. An example is just like the internet connection. So all apps can use internet, but that's still technically a permission that you need to add. So yeah, okay. So the text is a little bit small, but hopefully you can all read it. Okay. Yeah, so one thing is like just with permissions in general and like when you should request permissions or add them to your like manifest is you should really only put in the permissions your app absolutely needs to function. So like you basically want to like limit the amount of permissions that you're going to request from the user just to like keep the app secure. It's just like a Google guideline. So if you think like, oh, maybe later on I'll add this feature that will need a permission, like you shouldn't actually add the permission to your manifest until you actually like implement that feature. So another true or false. Yeah, okay. So I said this was false because like as Mihili showed in the last lecture, like animations are pretty easy to add on Android. Like usually just you just like add a modifier like animate content size and then it will like do most of the work for you. So yeah, I like highly recommend as you go on to develop apps in the future, adding animations, like it makes the app feel so much better, but like you barely even have to write any more code. So yeah, just a reminder to add animations to your app. All right. Here's the podium. And cool. Congrats to everyone there. So I'm gonna get started with the lecture. We have a bit of content to cover, but yeah, I think you'll all be able to get it. So yeah, today's lecture is on navigation and coroutines. So two extremely important topics in mobile development. I'll just jump right into it. We're gonna go over for navigation, what like the basics of navigation, how to implement the bottom nav bar, which is like a really common navigation pattern you see in tons of apps. And last but not least, coroutines, what are they? How do we use them? So we'll start with like a high level overview of what navigation actually is. So in a mobile app, the most common form of navigation that you'll see is something called stack navigation. And basically, the idea is that you maintain a stack of screens, And as you navigate, you push screens on top of your stack. And if you want to go backwards, you're popping them off of your stack. So if you're familiar with the stack, it's a like data structure in computer science, and this is basically like what this uses. And like a quick visual for you is like you might start on screen A and then navigate to screen B and screen C, and they'll be like placed on top of each other in this stack. So that's kind of like how you want to imagine your navigation graph when you're navigating. So that's like a bit high level, but we'll go into some specifics of Jetpack Compose navigation and like the ways to do it. So first is this nav controller right here. And the nav controller is basically responsible for dictating like what screen your app is on. And you get this controller using the remember nav controller like function. And that will give you this nav controller and you're going to be able to pass it in a bit later. But yeah, so let's like first go over how Compose navigation has evolved over the years. So this is actually new as of May 2024, like very recent, just this summer. Jetpack Compose navigation has released a beta for strongly typed navigation. So what that means is that previously Jetpack Compose navigation used something called routes. So if you're like on if you're on, let's say, the scheduler, right? You might, for pre-enroll, I just had pre-enroll this morning. You would be on like cornell.edu/scheduler/spring25, right? That would be like an example of the route name. And those like parameters, those things after the slash, basically tell the website like where to navigate. And Jetpack Compose actually had something very similar where all the routes could only be strings. But this was a problem if like, let's say I wanted to pass in like an integer to a screen. If I want a screen to like display a number, then I would kind of have to pass that as a string and just like convert it to a number. And it wasn't safe. Like you didn't really have many guarantees. But just recently, Compose released a beta for strongly typed navigation. So that's what I'm going to be going over today. Um, yeah, and as I said, we have the nav controller, right? This controls which screen you want to go to. Three main components to navigation. So nav controller, the nav host, and the nav host is something that you're going to place at the root of your app. And it's basically just going to like tell your app which screen to display. So your nav host, you're going to pass in the nav controller to your nav host, and then the nav host will essentially like resolve the state of the nav controller and figure out which screen it needs to display. And then the one last like high level concept here is the nav backstack entry. So this basically is like imagine you could get a view of like what the top of your navigation stack looks like at any time. That is like the nav backstack entry, and it will contain like all of the parameters that you might be passing between screens. So yeah. And again, like just a reminder of how things used to work. So before we would have a nav host set up like that, we'd pass in the nav controller, like I mentioned, and some start destination. And then the thing is that we would actually have we like in the nav controller, right? We have this nav graph builder scope that we can use to place in our composables. So we would say composable, and then we specify the route name. And then you would like write whatever composable code that you want to. And then whenever you navigate to that route, it would just display that composable code in your app. So yeah, the nav host is always something you have like at the root of your application. Yeah, so this is like kind of the like a bit of an older way of doing it, and you'll probably see it on a lot of Compose apps. Any questions about this so far? Okay, so now we can get into the new way, which is using something called serializable data classes to basically add types to our navigation system. So I want to go over like I'm going to go over some like very core Kotlin concepts that are like super important to Android development, and then we're essentially going to combine all of these to explain like how we can use these concepts to improve the navigation experience. So the first is a data class. In Kotlin, a data class is basically just like a regular class, but we have like useful functions like equals, toString. These are defined for us. And another important thing about a data class is that it's really only for storing data. So a data class like should not have functions, you know? It should just like an example would be like a user, right? And a user might have members to it, such as like an ID, a username, like other points of data, like usually like primitive types that we can have in this data class. So that's one of the three. Um, yeah, and yeah, as I said, should only be used for representing data, right? And another restriction of data classes is that the primary constructor needs at least one parameter. Like all that means is that you can't have like an empty data class, you know? I couldn't have like a user that has no properties. So you have to have at least one property. Yeah, and here's the example. So cool. Okay, now another concept, serializable. So basically, anything that has a valid JSON representation is considered serializable. So if you're not familiar with JSON, it's basically it stands for JavaScript Object Notation. It's basically just a way that we can represent objects as a string. So you can see below there, that is like what this user could look like in the JSON format, right? And basically, as an example of something that like might not be, let me see, do I have a slide on this? Not yet. Okay. So, an example of something that might not be serializable would be like if the user class had a function, right? How could I serialize that function? Because that function is code, and I would have to essentially like represent that code as a string, and like that just like wouldn't really make any sense because at the end of the day, like a function is a behavior, you know? Even though like you could actually write out the code as a string, like that would not really be a good idea because you'd have no way of like kind of comparing like whether two functions are equal, right? Like two functions are equal if their behavior is the same thing, but there's a lot of different ways to write functions that have the same behavior. So yeah, maybe that's like a bit of a tangent, but I guess like the point is that like typically objects that are serializable, they're more just like these like structures where it's just you have like a data class that has these like different primitive fields, and then you're able to write them out as a string. And to make something serializable in Kotlin, we have to add this at serializable annotation. And it basically just marks like to the program that, hey, this data class like has a valid JSON representation. Any questions on that? So I think that could definitely be confusing, especially if you haven't worked with JSON before. Okay. And then the next like super important concept in Kotlin is sealed class. So this is an abstract class where all classes that extend the class can only exist within the class. So first, let's go over like what an abstract class actually is. So an abstract class is basically, I think like an example is probably the best here. So an abstract class is like a class that typically like we can't really instantiate it by itself. So an example of this is like a dog breed, right? So a dog breed, like we can't have a dog breed that is just equal to dog breed. We didn't specify what breed of dog it is. So like this like doesn't really make any sense, right? So that's kind of like the idea of an abstract class is that it's a class that we can't actually like create an instance of it, and it more just like specifies like common behavior that the inheritors will have. So this dog breed is an abstract class, right? That's one component of the sealed class. And the other component of the sealed class is that all of the inheritors have to be inside of these curly braces. So we have like a puppy and a bulldog, right? These are like two dog breeds. But these are the only dog breeds like in our entire app. And we have that guarantee because of the sealed class. Okay. So yeah, so just like an example, so these two statements are valid. We're able to initialize dog breeds using the subclasses of dog breeds, so puppy and bulldog. We cannot instantiate a dog breed that's not one of these types. So another way to think of this is like a union type, as in a dog breed has to be a puppy or a bulldog. It's one or the other, right? And then if we try to make a new dog breed that extends the dog breed sealed class, we're going to get an error because we can only extend a sealed class like within these curly braces, like within that class, I guess. So, yeah, I definitely think I went a bit faster there. If you don't have like object-oriented programming experience, you probably have questions, or even if you do, you probably have questions. So, yeah, ask away. Yeah. Yeah, that's a really great question, and actually what I was about to answer on the next slide. So, here's an example of like why this might be a useful notion. So let's say that like for some reason you're trying to get like the approximate age of a dog, I guess. And basically you want to have different behavior for each dog breed, right? So what I can do is use a when statement here, and I can check like if the dog breed is a puppy, then I can just return its age, right? Because I know for sure that this dog breed is a puppy and puppy has an age, right? But if it's a bulldog, then maybe I need to do some like approximate calculation of what its age might be. So I'd say, okay, we're going to take its strength and divide it by 10, right? So this is also something that you can do in an abstract class. You can take like a dog breed and you can check like what subclass it might be. But the main difference is that with a sealed class, the compiler knows that all of the inheritors are in these curly braces. So basically that means that like I don't have to add, usually I'd have to add an else case here in this when statement. I'd have to have an else case because I wouldn't know for sure that I've checked every single inheritor of the abstract class. But because dog breed is a sealed class, and we know we have guarantees that all of the inheritors are within these curly braces, we know for sure we've checked every single case, and we don't have to put that else. So it's a really nice way of like basically representing this like union type where a dog breed is either a puppy or a bulldog and it can't be anything else. And then that allows us to be able to like check and like correspond each class to a very specific like implementation, I guess. Does that answer your question? Okay, cool. Any other questions? Okay, cool. Yeah, we're making pretty good time. So now putting it all together, so why did I bother just teaching you those three like seemingly unrelated concepts? And that is this like representation of a screen that or like a route that I want to provide. This new representation that basically allows our navigation to be typed. Okay. So we're going to use a sealed class. And the reason for using a sealed class is now like whenever we have a screen, we know it's going to be like one of these screens in our app, right? And this will just give us that guarantee where we can like check, we can like do different behavior based on what screen we're on. So we're using a sealed class to represent a screen. And remember how before in the old version of Compose, routes were represented as strings. And we still have that constraint in some way. But the thing is that when we annotate it with @serializable, this tells Kotlin that this data class can be represented as a string, right? Or this like data object, it can be represented as a string. And then Kotlin will essentially take care of these string representations for us. It will like do the work behind the scenes to basically yeah, like create and parse these string representations, these routes that we had before that like we would have to essentially like get a key from the route and then like check the key's type and just do like kind of like more manual string parsing. Like here, Colin is going to do all of that for us as long as we can guarantee that the data classes that we have are serializable. And then this like wrapping it in a sealed class is like an organizational choice that just allows us to have all of our screens in one place and have like really strong guarantees about where we actually are in the app. So, yeah, and then one thing I didn't go over is this data object. So a data object, and like in some older versions of Kotlin, you'll just use the word object. But basically, all it is you can kind of think of it as just like a data class with like no parameters. So like a data class must have at least one property, but sometimes you might want just like the name of a class that like doesn't really have any properties, right? Like setting screen, I'm not going to pass in any parameters to setting screen. So I just have that as a data object. But for a profile screen, if I'm viewing someone's profile, I need a user ID. So I specify that parameter here. And then let's see, do I have a slide on this? Okay, I don't have a slide on this. But basically, like the idea is that when we use our nav backstack entry that I mentioned earlier, Kotlin can automatically convert it to like one of these representations, right? Like basically it could convert it like if we're in the profile screen and we want to figure out our user ID, it could convert it to it could convert the route parameters to an instance of this data class. And then we just need to use dot user ID to access the user ID. And this gets like even more useful when your classes have more parameters. So yeah, we're gonna get more like a lot more in depth into this on Wednesday because Wednesday the whole demo is dedicated to navigation. But yeah, does anyone have like any questions on what this means? Okay, cool. Yeah. And yeah, so we will like do a more concrete example on Wednesday. So that should give you some more intuition as well. But like basically just the main idea of this slide is that we want like a central organized way to write out like what all of our screens will be called, like how we can navigate to them, and like what parameters we need to pass to those screens. Okay. So yeah, for now I'm going to skip the demo for this is on Wednesday. So we're just going to jump right into coroutines, which can be like a more challenging concept, I would say. So I want to make sure I leave proper time to explain everything. Okay, so the idea of coroutines, these are super, super important. We have a computation that's going to take a long time. A really common example in apps is a network request. And we don't want to just the UI to just completely freeze whenever we send a network request, right? If we didn't have coroutines, your apps would basically just be like freezing and like it would show like a little bit, you could move around, it would freeze again and freeze again. It would just keep freezing because like we don't have any way to do work in the background, right? We need to have a way to perform computations in parallel as we operate the UI. So this is an extremely important idea. And Kotlin like came up with a solution for this that makes it like pretty easy because like parallel tasks, it's like usually pretty hard to reason about like when you have multiple processes running at once. But Coroutines provides a framework to manage all of this and make sure that we're doing it safely. So first, I'm going to like teach you about something called scope. So this is like another Kotlin concept, and you'll like see why we need to know this in a bit. But basically, the main idea is that some extension functions allow us to work within a specific scope. And a scope introduces what we call a context object that we have access to. So I think this is much easier explained through an example. So dot run is an extension function on like basically I think like any type in Kotlin you can use this. And it allows you to run code with the current object as the context object. So what that means is like, let's say we have this list and we do dot run, right? Any code inside these curly braces will have access to the parameters of the list as if it was inside of the list class. So like, for example, you can see I didn't like define a variable size anywhere, but I'm actually able to just print it. And that's because the list of strings has a size property that we can use, right? So like imagine that you were inside of the list of string class and you made another method in that class. You would have access to all the properties of the class to use when you're writing that block of code, right? So this is really the same thing. It's just giving us a way to write code like as if we're inside of the class. And like here I'm calling like a function that's in the list class. I'm using the first, right? And then here I use another dot run. So now it's as if we're inside of the string class because first basically returns the first element of the list. So this is equivalent to saying like quote unquote hello dot run, right? And then inside of these curly braces, we actually get access to like all of the member properties and functions of the string class to use. So here we print its length and we didn't declare that variable. We're just using it like as if we're inside of the string class. So yeah, is there any questions on like on how scope works? Okay, cool. And another like really cool example of scope that I remember like when I first discovered this, like my mind was kind of blown because I feel like a lot of the time using Jetpack Compose, it can feel like black magic, you know? Like how do we have access to this like when we're in a lazy column and we need to put in list items, right? How do we have access to this item function? Like who provides access to this? Who provides access to sticky header, right? When I'm working on a composable inside of an item, how does the compiler just like magically know that I can use the animate item placement modifier. 'Cause this modifier, it wouldn't make sense unless we're in a lazy column, right? And the solution is actually scopes. That's the really cool thing about this. So the parameter to a lazy column is this like content function, right? And like seeing these curly braces, you might expect it to just be like parentheses arrow unit, just like a regular function, right? But what the type actually is this lazy list scope dot parentheses arrow unit. So like what this means is we're basically declaring an extension function on the lazy list scope. And remember, when we declare extension functions on a class, where it's almost like we're writing code like within that class. So that means we actually get access to all the like functions inside of lazy list scope. And those functions, they include sticky header, they include item, right? It even includes an extension function on the modifier class within the lazy list scope called animate item placement. So like breaking down the magic of, how Jetpack Compose works, it's not only just like cool to understand, but it can also be practically useful. And I'll show you an example. So this is like a problem that we face in Eatery, which is that we had this like screen that was a giant lazy column, and we wanted to be able to scroll through this screen very efficiently. But the thing is that we were showing a menu, and we had to show the category as one item, and then like all the items within that category as like separate list items, right? We wanted to have everything be like separate list items, just to like like because it just makes sense when you're creating like a lazy list. You want each menu item to be separate. And the thing is, like, if you wanted to abstract this menu away into a composable function, right? Then we kind of like run into this problem where we actually can't call the items function here, since we're not in a lazy column, right? We're in this composable function. So if we wanted to create an item that displays the heading and then create items that displays the items that are in the category, right? I can't actually do that inside of this eatery menu. Okay. So question, are we cooked, or is there a solution here using like the kind of stuff that I just went over? So yeah, it's pretty hard to spot, but like does anyone have any guesses on a way that we might be able to abstract away the like being able to call these items here? Yeah. Um Yeah, so using run, that's like kind of the right idea, where it's like where we definitely want to use like the idea of context. But what do you think like we would be able to like call dot run on? Do you have any idea of that? Yeah. Yeah, so that's kind of like the problem with that idea, right? But yeah, any other guesses? That was a good guess though. Okay, so I'll show you what I end up doing, which was basically you can create an extension function on lazy list scope, right? So remember how before I was saying that like lazy list scope basically gave us access to all of these functions, right? And think about like what type the content is, right? It's this lazy list scope dot parentheses arrow unit. So I just thought, okay, what if I like made my own extension function on this lazy list scope? And then it's basically like adding another function, right? So like we can add functions to classes we can't modify, right? We can't modify lazy list scope, but we can add an extension function to it and like extend its behavior. So basically I added a an extension function called menu items, right? And then that, like, because we're inside of the lazy list scope, we have access to its methods. So I could call the item function here, and then I could render a composable, and I could even call like the items index function and render composables based off of that. And you can see in our lazy column, right, all I have to do is just call this menu items function, because we like essentially extend it. We use an extension function to extend the lazy list scope interface to include this like menu items. And I feel like if I didn't like have an understanding of scopes, I would not really have like been able to come up with this, right? If like the being able to use the item function is just black magic, then it's like you're not really going to be able to understand like how you could create something like this. So yeah, like yeah, it's totally fine if you don't have like this intuition just yet where you'd be able to like think of something like this. But the main idea is that like having like this like deep knowledge, as I call it, where it's like you kind of understand like the internals of what's going on, like can help you be a better developer. Um, but okay, so back to coroutines. Why was I talking about scope? Well, basically, we have this concept of a coroutine scope, and that, just like all other scopes, provides a context object. And this context object contains information about like the environment that the coroutine is being launched in, its behavior, and like what dispatcher it uses, which like we'll explain that a bit later. But basically, like the idea is that these threads, or like these coroutines are kind of dangerous in that we're starting this like whole other process, right? And we need a way to like manage these processes so they don't just like run forever or like change something that like we don't expect. Like we need to be able to like cancel them and stuff like that. So we have to launch them inside of a certain scope, and that scope is called a coroutine scope. Yeah, I don't think I've stopped for questions actually about scopes. So, does anyone have any questions about this so far? Okay, hopefully you aren't like too confused to even create a question. But yeah, is anyone just like too confused to even create a question? You could just raise your hand. No shame. Okay, I guess it's going pretty good then. Cool. Yeah, so here's like a okay, actually I don't know why I put basic example. This isn't actually that basic. But yeah, so basically we have this keyword suspend. And suspend basically says that this function has behavior that like okay, so I guess like this explanation says that it will yield control to the coroutine scheduler when executed. So what does that like actually mean, right? So remember how like I was saying that um it says like coroutines we can only call them inside of a coroutine scope. And that coroutine scope basically provides a scheduler for your coroutines, right? And it manages your coroutines. So whenever you call a suspend function, you're basically just saying that you have a function that's going to run for a long time. And because of that, like you need to make sure that you like handle that properly. So let's say that I was like in the UI and I had a button, right? And on when I click that button, I wanted to call a function that was going to run for a long time. Compose, like Jetpack Compose doesn't like allow you to freeze the UI, or like they don't want you to. You could, but they don't want you to. So what they do is they force you to launch it in a coroutine scope. And that basically ensures that like your function is going to like usually launch in another thread and like be managed by some like scheduler. Um and launch is like a keyword that you use to run tasks in the background. So like in a way this might seem intimidating like but it's actually not too bad. So what we're doing is we establish a coroutine scope because launch like is actually a suspend function because it's going to run this code inside here, which might take a long time. So what would happen here is you'd go inside this coroutine scope, right? Is network loaded would be false. And then we launch this. And because this is launch, it's running a task in the background. So we would hit this delay, but then we'd actually go immediately down to this like while true loop, right? And this while true, like you can kind of think of this as like our UI, where it's like always showing that we have like some resource loading if the resource is not loaded. And then once the resource is loaded, it's gonna like show that resource, right? And like the UI is like being drawn every frame. So that's kind of why we have this like while true. So you can kind of like imagine this part to be the UI. And then we're launching some task in the background. So in this case, our task is like this fake network request where it takes 1 second to retrieve information from the internet and then we set network loaded equal to true. So yeah, the point is like we want to immediately show our UI. So like this would essentially run in the background. And yeah, it's just trying to give you like a bit more intuition on like how to use coroutines. And like I think like the main thing, like the key concept here is that launch when we execute it, it's going to just like start running in the background, and then this code will like it pretty much immediately run. So yeah, that's the basic example. But okay, let's see what we have next. Yeah, so another example, this is actually more basic, but I really like this visual. So what happens is we first call a coroutine scope, right? And we're going to repeat this 1,000 times, and we're going to launch this fetch docs command, okay? And we don't really know like how this is implemented, but we can like assume that it's some long running task. And launch, again, right? It's going to run it in the background. So we're actually going to launch like 1,000 of these requests almost instantly. And you can see that's kind of what this like GIF is displaying here. So we launch all of these requests. And this arrow to the coroutine scope means that the coroutine scope is managing these requests. So the coroutine scope only finishes when all of its child coroutines finish. And you can see that animation is kind of displaying that. So yeah, as we just start by like this suspend function actually means that like when we call load lots, we're going to be like we can only call load lots in a coroutine scope itself because it's a suspend function. So that's why this says callers coroutine scope here. Um, so yeah, we start in the callers coroutine scope, then we create like a child coroutine scope. Um, and then that child coroutine scope launches a bunch of its own coroutines. And then a parent coroutine scope will only finish when all of its child coroutines are finished. So that is like what this visual is demonstrating. So yeah, any questions on what's going on here? Okay. Yeah. So one question you might have is like, why bother with scope? You know, why do we need like this way of managing our coroutines? Like, what is like dangerous about just running launch? And here's an example. So, in Android, you have there's this thing called global scope. You should never use this. That's why it says bad code here. Don't use global scope. But what global scope does is it's like a coroutine scheduler that is at like the root level of your application. So the coroutines that you launch in global scope will only dispose when like the entire app is disposed of. And that could cause a memory leak. So let's say I like write some bad code that has like this infinite loop here. It's just infinitely incrementing this integer, right? And this is running in the global scope of the app. And like the thing is, this coroutine will never, well, it basically never get disposed until we actually close the app. So now you're like hogging resources on this person's phone, like you're hogging like a thread or like at least like some computation on their phone because you didn't like use scopes properly, right? You use this global scope, which is just always running. And like as you'll see when we like get to more advanced lectures with like how to actually organize your networking code and like where to put your networking code, which is like you'll see that scopes are tied to the life cycle of an app component, which means that like some component of your app, um, like let's say it's like a screen, right? Let's say that I navigate from screen A to screen B, but like screen A, I have a lot of different like long running jobs that I launch from screen A. And like ideally, I want whenever I leave screen A, I want like all of those jobs to be cleaned up. So maybe screen A would have like its own scope that I would launch those coroutines in, and then when I navigate away, they would like all automatically be disposed of. So yeah, that's why we bother with scope. We want to like avoid memory leaks as much as possible. So yeah. Okay, cool. So now for like some exercises with scopes. So here we have this like main suspend function, and we have like a little example. So what do we think will be printed here? And like one thing I didn't really actually mention is that coroutines like are cancelable. That's another important property. Like you can pause them, you can cancel them, which is like super helpful. But yeah, so you can see like here we create this job and we launch it and we do some things in this job and then 1.5 seconds later we like cancel this job. So yeah, let's see what do we think will be like printed here? Give you a bit to think about it. Yeah, yeah, that's right. Do you want to explain why? Yeah, exactly. Yeah. That's perfect. So yeah, that prints hello world. Very nice job. Yeah. Cool. Okay. So then now what ha if I like remove that cancel, what do we think would happen? Yeah. Yeah, exactly. Yeah, and like that might have like seemed like a simple question, but I feel like it is kind of more complicated than you might initially think. Because if I run like launch, right? Like it's very easy to think of launch as it's just like we run this code in the background, right? But the thing is that there's nothing after this curly brace. So like a question that you might have, and that I had when I was first learning coroutines is like, how do we know that the program doesn't just end when we reach this line, right? Because we basically instantly reach this line. We launch and then we get to here and like that's the end of our program. So how does our program like how do we know for sure our program doesn't end? And the answer is that like we had um we, like as I specified in that like in the GIF that I showed is that the core like a coroutine scope will only finish when all of its children coroutines are finished. So what happens here is we launch a coroutine scope and then we create a coroutine here. So this job is a coroutine. And this job has two child coroutines. So this job will only be done when both of its child coroutines are done. And we can see that that takes 2 seconds, right? So it takes 2 seconds. These child coroutines finish, then this coroutine finishes, and then it goes back up, and that coroutine finishes. So yeah, it's something to think about. Um, yeah, that's the big lesson. Coroutines finish when their children coroutines are finished. This is like a pretty important concept. And like gives you some like intuition as for like the point of scope and like why we want scope in our app, which is like managing these coroutines. Cool. Okay, so another exercise. Uh, I'll let you guys think about it for a bit and yeah, raise your hand if you have an idea. Might be helpful to kind of like type out what it prints in order instead of like trying to keep it all in your head. But okay. I think since I do want to show like a bit of code for coroutines, I'm just going to give you guys this one because I feel like it's actually not really like showing any new concepts. It's kind of just like an exercise. So let's go through it together. So like we launched these two blocks, but we have delays. So let's just like ignore those for now. So three is like the first thing that we're going to print. And now we have another delay. So we should like compare this with the delays we previously had. So we have 2000 and 1000. And we can see that like 1000 is going to finish before 1500. So we'd have 3, 1, right? And then we have 4. So 314. And then we have another delay. So now we have to go back and compare. So now we're at like 1750, right? And 1750 is going to finish still before 2000. So we're going to get 5. And then finally we're going to get 2. So yay, I did it. Cool. Any questions on that? Okay, great. And then like the last concept for coroutines is dispatchers. So basically, like the mobile resources tend to be kind of limited, and we have whenever we start like a new thread, kind of like a new process that's doing computation, we need to tell the system like where we want this process to go. Like what kind of compute do we want to use for this process? So there are three different ones. IO is going to be like the most commonly used. And that's going to be for like network requests and anything with like file storage, because that like tends to take a long time. Then main is the dispatcher for UI operations. Usually UI operations aren't like super long running, so you like really rarely need this one. And then the other one is default. So like if you like doing big calculations like CPU heavy, you want to use the default dispatcher. And the way that your coroutines like know what dispatcher they're like being deployed on is through the coroutine context. So it uses that context object to know what dispatcher it's being deployed on. Yeah, okay, cool. So let's go into like a quick demo. Um, don't feel the need to like follow along, I would say. You can just I think just like if you take a bit to just look at how I'm doing it, I think it should give some intuition. So let me see if I can do this pretty quickly. Um, yeah, okay, cool. Okay, so basically, let's see, we have 2 minutes. Okay, I might go like a little bit over. Feel free to just like head out if you need to. But let me see. So I think I just started a new project. I don't know why it's not showing. Okay, cool. Okay, let me see if I can mirror this. Uh, mirror. Perfect. Okay, cool. Yeah, so let's like create a long running um like function. So we're gonna do the like naive implementation of Fibonacci numbers. So we're going to just like add this function that's going to take in a number n and like return a Fibonacci number. So we're starting with like the base cases, right? So it could be 1 and return 1. Um, and then otherwise we're just going to return the previous Fibonacci number, or like the sum of the previous two Fibonacci numbers. So yeah, just like a recursive function. Let me turn on the formatting really quick. Okay. Yeah, so just like a basic recursive function. And then we want to like try calling this function in our code. So let's just do like a button here. Uh, and we're gonna say on click. Um, and we're gonna have, let's just say Fibonacci number. Um, and we're gonna just make this a mutable in state of 0. So we're just gonna start off with 0. And then on click, we want to set our Fibonacci number to Fibonacci, and let's just say like 40. So that's going to take a long time. Um, yeah, and then our text will say Fibonacci is Fibonacci number. Cool. Okay. So this is going to take a long time, which is not good. So let's just see like what happens if we run our app now and like try to like use this function to compute the 40th Fibonacci number. Um yeah, but basically, like the way that we're gonna fix this is like by using coroutines, and we're actually gonna use dispatchers as well to make sure that it's like on the right it yeah the to make sure that the computation happens on the right thread. While I'm waiting for this to run, I'm gonna like start on the coroutines implementation for the sake of time. So yeah, I don't think this should be like too like what I have so far shouldn't be too challenging for anyone, but. Okay, cool. And let's see what happens if we click on this. Okay, you saw like the button froze, like the animation on the button completely froze, and then we had our Fibonacci number load. So let's try to fix this. The first thing that we need is a coroutine scope, right? So the way that we do that is we just say val coroutine scope equals remember coroutine scope. And this coroutine scope is bound to the life cycle of this composable. So what's really cool is that like if when this composable function leaves the screen, then all of its child coroutines from this coroutine scope will get disposed. So we don't have to worry about like causing a memory leak with like a crazy Fibonacci number calculation. And now all we have to do is change this onClick method to we want to launch something with the coroutine scope. And then we're going to put in like our Fibonacci number. So I'm gonna like change that to 41 because 40 was like a bit too fast. And we'll see how this works. So let's see what happens if we click it. And yeah, you can see it still froze. Does anyone have any idea why it still might have froze? Like we're launching a coroutine scope here, right? We should be doing it in another thread. So why on earth is it still freezing? Like what could I possibly be doing wrong? Wouldn't it be funny if I didn't know? No, I do actually know. Um, it actually has to do with the dispatcher that we're using, right? So let me bring up this slide again. So we have three main dispatchers. I don't know why my screen is frozen. Hopefully that'll fix. Okay. So IO, main, and default, right? So my question for you is like, what like considering that our app still froze, so what dispatcher do you think we were using? Anyone have an idea? We saw the UI froze. So what dispatcher do you think we used to launch that Fibonacci number? Yeah, main, exactly. So remember coroutine scope actually by default uses the main dispatcher. And that caused it to run to try to like run with the UI operations. And we still froze. So let's go back. And now we're going to update this dispatcher. Um, and we're going to use dispatchers dot defaults, right? Because Fibonacci number, that's a CPU heavy calculation. So we're going to put that on the default dispatcher. And let's see if this works. I really hope it does. Yeah, you saw our animation was like very clean there. The app didn't freeze, which was good. I can like zoom in and show it again if you don't believe me. But yeah, pretty cool. That's a very short coroutines demo. Sorry I went over, but thank you for staying, and feel free to come with questions as well at the end if you have any. So yeah, thanks everyone. All right, fast pace, but like I think it went well. All right, assumption.